Hi, welcome to an Arduino tutorial from Robojax. My name is Ahmad Shamshiri. In this tutorial I'm going to show you how we can measure up to 100 ampere using this shunt resistor of 50 ampere or 100 ampere 75 millivolts on the LCD screen with Arduino. As you can see, 60 ampere is taken by the load and we are reading 60 ampere, approximately 60 ampere with 5% error. You can get the code for this by clicking at the link below the video in the description, which will take you to robojax.com/learn/Arduino. Let's get started with this. I've separate video explaining this shunt resistor fully and how this works, and I have a complete video about that. Make sure to watch that video because in this video I'm not going through that, so that is required. Please watch that. After watching that, also make sure to get the code and watch the video of introduction to this LCD, and make sure that you're able to display a text on this and download the library. Once you use this separately and succeeded, and once you use this, the video introduction to this, and were able to display the current, then come to this. Otherwise, this one you will get a lot of error and issues. There are many ways to measure current with Arduino, including different type of sensors made for this purpose. And I have a lot of videos related to those. I try to put the link below this video in the description, but this one we're using this shunt resistor that is sourced separately, and this has 75 millivolts rating, and we are going to use analog read of Arduino to read that voltage and do the calculation to display the current or get the current for other purpose that you want. This shunt resistor is sold for different current rating. For this shunt resistor, there are two versions sold. This is a 100 ampere 75 millivolts, and as you can see, this is 0.5% tolerance version, and this is a 50 ampere 75 millivolts, same thing, but this is smaller and it has plastic. So on the one hand, this is better because you can install and attach it to something, and this is already insulated, but it has smaller connector. And 100 ampere, because it's twice as much the current, then there is no such thing, but it has huge nuts and you have to have proper wiring for this. The positive goes to the load and comes here and passes through this shunt resistor to the negative terminal. So this is in series with the load, and we will be getting two terminal here. The ground is from the side where the battery is connected, and this side will be automatically positive because the positive goes here and comes here. So this point is positive with respect to this point, and we are going to connect it to Arduino to read it. Or you can connect it the other way and put the shunt resistor at that positive terminal and the negative on this side. In this case, the positive comes on this side because the battery terminal is here, so this point is positive with respect to this point, and this is now negative, so we will be connecting this to Arduino to read it. But anything below 10 ampere, this is not a good choice. You will get a lot of error. Now let me explain the wiring. I'm using electronic load as my load, where the power is connected to my electronic load. I'll be connecting it like this. My load is here. I will put this in series between the negative terminal and the load. If you want, you can also do it this way. I'm doing it this way. This is the electronic load DL3031, and these are the two terminals that from the circuit will be connected in here, and we will see the voltage here and the current. As you saw, this has been connected to electronic load. This is coming from my negative of power supply, coming and passing from here, and this goes to the negative terminal of my electronic load. And from these 2 points I've taken these 2 wires. The side that is connected to the negative terminal of power supply is my negative, and this side is automatically positive. That black wire is connected to this point, to ground, and the red from this side, this is a positive, this has been connected to analog 0. LCD screen, we have 4 wires here. The wires for this LCD have been labeled as ground, will be connected to ground, VCC, SDA and SCL. Ground is connected using black wire to ground of Arduino. The second wire is VCC, this has been connected to 5 volts of Arduino. This gray is SDA, it has been connected to analog 5, and the last one is a purple, that is SCL, it has been connected to this pin A5. You can also connect it to SDA and SCL at this point. And if you're using multiple devices, put a wire from here. So you can, in parallel, you can connect up to 128 different devices. You have to have very thick cable to handle the current. You have to have very thick cable to handle the current. I'm using a very short cable here. After this point I have very thick cable. You see 2 of them are connected here in parallel to handle this. And actually for my power supply, this is a cable that I'm using. And if you see and compare it with this, you know that this is a very thick cable. Now let me explain the code. We have defined here the constant integer N pin. That is where we read the analog pin, the voltage from the shunt. Shunt current is the amount of shunt resistor that you have. Either you have to enter here 50 or 100 or whatever value you have. As you can see, this is 100, and I've entered 100, and if you have 50, just enter 50, that's the value. 75 millivolts is entered as 75. Do not worry about 0.075 in terms of millivolts. And the correction factor with this setting that I have, 2 is here because of the reference voltage. And this line you have to download and include it. I've explained that you need to watch that video separately. I'm not going to explain it. This is for Arduino library. This is for liquid crystal library. And in this line we enter the I2C address for the module. For this has an address. I have separate video explaining that, but for this you can run I2C scanner. You need to run I2C scanner. I will provide you this code, just upload it. And once you upload it, open the serial monitor, and it will print the address for you. As you can see, it shows 0x mean hexadecimal and 26, and that's why I entered here 026x, and then 16 is number of character, 2 is number of lines. And if you're using 2004, it will work as well fine. Just put 20 and then put 4 here. Iteration is 30. Iteration we are measuring out of 30 measurement. If you want to increase the accuracy, perhaps go to 50, but it will be slower. Voltage reference, this is used internally by Arduino, 1.1 volts, and we have bumped it in terms of millivolts, so 1100, and bit resolution is 10. Depending on your module, if you have Arduino DUI and MKR, it will be 12, so enter here 12. And then debug true is for the debug purpose. Inside the loop, this is just printing LCD display, and put get current. This will send the current to this point on the LCD. Otherwise, we send LCD, we send 00. That's why we are getting that 00 when there is no current. And now here is the demonstration. As you can see, currently it is 50 ampere. Let me change the current to 40 ampere. the current is shown here 40, and now we are reading 40 ampere here with a little fluctuation or variation, which is normal for this type of shunt. Go 30 ampere. Now I just put it at 30, and we are reading about 30 ampere current here. And let's go for 20, and here the current is now 20 ampere, and we are reading 20 ampere on the LCD. Let's go to 10 ampere, and lower current we will get slowly a little error, but below 10 is not measurable. Now pay attention here, because if you want to measure less than 10 ampere, then there are very good sensors for that purpose. You can get it very tiny and you can measure it. I have separate video for those. The link is below the video in the description. Let's go 5 ampere. Still acceptable, but perhaps below this we will get error. Let's go to 2 ampere. And this is where we get error. So anything that you want to do, measure the current above 5 ampere and preferably 10 to 50 ampere. And there is a 100 ampere version of it. And here now I'm connecting the 100 ampere shunt and changing the code to 100. Make sure this is 100. Upload the code, and here is a demonstration with 100 ampere 75 millivolts shunt. I have to make sure that I have a surface here that is non-conductive connected. Right now the current is 0, as you can see. Let me go 20 ampere and turn it on. So with 100 ampere we are reading this value. Let's go 30 ampere. So still acceptable. Let's go 40 ampere. Right now 40 ampere is being drawn, electronic load, and let's go 50 ampere. Now electronic load is taking 50 ampere, and this is our reading. Let's go 60 ampere. And right now this is the maximum that I can test with. 60 ampere current is being drawn, and this is now displaying it. And if you go even 100, perfectly it will display with. Thanks for watching. This was how to use the shunt resistor with Arduino to measure DC current. If you like this video and learned something, please thumb up, as this will help my video in the search algorithm of YouTube. If you have comment or question, post it at the comment section below. I try to answer and reply. If you want to get updates of my upcoming videos, make sure to subscribe. I'm going to show you how we can measure any DC voltage with Arduino. As you can see now, it is 12 volts and we are reading 12 volts and serial monitor. I'm going to explain how to calculate different resistors to measure any voltage, also demonstrate 12 volts, 24 volts, 36 volts and 50 volts. Hi, welcome to an Arduino tutorial from Robojax. In this video we are going to see how we can use this Allegro ACS712 current sensor to measure the current and display the current on the LCD1602 or on this 2004 with 4-line display module.